A hard hat is a type of helmet predominantly used in workplace environments such as industrial or construction sites to protect the head from injury due to falling objects, impact with other objects, debris, rain, and electric shock. Suspension bands inside the helmet spreads the helmet's weight and the force of any impact over the top of the head. A suspension also provides space of approximately 30 mm between the helmet's shell and the wearer's head, so that if an object strikes the shell, the impact is less likely to be transmitted directly to the skull. Some helmet shells have a midline reinforcement ridge to improve impact resistance. Blue-collar workers, especially union shop construction workers engaged in occupations that require protective equipment, are sometimes referred to as hard hats. A bump cap is a lightweight hard hat using a simplified suspension or padding and a chin strap. Bump caps are used where there is a possibility of scraping or bumping one's head on equipment or structure projections, but are not sufficient to absorb large impacts, such as that from a tool dropped from several stories. History. In the early years of the shipbuilding industry, workers covered their hats with pitch, and set them in the sun to cure, a common practice for dock workers in constant danger of being hit on the head by objects dropped from ship decks. Management professor Peter Drucker credited writer Franz Kafka with developing the first civilian hard hat while employed at the Workers' Accident Insurance Institute for the Kingdom of Bohemia, but this information is not supported by any document from his employer. In the United States, the E.D. Bullard Company was a mining equipment firm in California created by Edward Dickinson Bullard in 1898, a veteran of the industrial safety business for 20 years. The company sold protective hats made of leather. His son, E. W. Bullard, returned home from World War I with a steel helmet that provided him with ideas to improve industrial safety. In 1919 Bullard patented a hard-boiled hat made of steamed canvas, glue and black paint. That same year, the U.S. Navy commissioned Bullard to create a shipyard protective cap that began the widespread use of hard hats. Not long after, Bullard developed an internal suspension to provide a more effective hat. These early designs bore a resemblance to the military M1917 Brodie helmet that served as their inspiration. On the Hoover Dam project in 1931, hard hat use was mandated by 6 companies, incorporated. In 1933, construction began on the Golden Gate Bridge in San Francisco, California. Construction workers were required to wear hard hats, by order of Joseph Strauss, project chief engineer. Strauss strove to create a safe workplace. Hence, he installed safety nets and required hard hats to be worn while on the job site. Strauss also asked Bullard to create a hard hat to protect workers who performed sandblasting. Bullard produced a design that covered the worker's face, provided a window for vision and a supply of fresh air via a hose connected to an air compressor. In those times many workmen's safety helmets were made of steel. Aluminum became a standard for hard hats around 1938, except for electrical applications. MSA introduced the new plastic skullguard, a registered trademark helmet, in 1930 for the metals industry to withstand radiant heat loads of up to 350 degrees Fahrenheit. New plastic bakelite was used to provide protection rigid enough to withstand hard sudden impacts within a high-heat environment but still be light enough for practical use. Machinery of the times required that helmet materials used be electrically non-conducting. Bakelite resin compounded with wire screen and linen. The skullguard helmet is still manufactured. MSA also produced a low-crown version for coal miners known as Comfo Carp, a registered trademark headgear. Coal miners were quick to take up MSA a unregistered trademark low-crown version of the headwear called Comfo caps. Fiberglass came into use in the 1940s. Thermoplastics took over in the 1950s, as they are easy to mold and shape with heat and cost less to manufacture. Today, most hard hats are made from high-density polyethylene or advanced engineering resins, such as Ultem. In 1952, MSA offered the shockguard helmet to protect electrical linemen from electrical shock of up to 10,000 volts. In 1961, MSA released the Topeguard, a registered trademark helmet, the first polycarbonate hard hat. 1962 brought the V-Guard, a registered trademark helmet that today is the most widely used hard hat in the United States. In 1997 ANSI allowed the development of a ventilated hard hat to keep wearers cooler. Accessories such as face shields, sun visors, earmuffs, and perspiration-absorbing lining cloths could also be used. Today, attachments include radios, walkie-talkies, pagers, and cameras. Another milestone was reached in 2013 with production of the MSA V-Guard Green Helmet, the first industrial safety product produced from nearly 100% renewable resources. High-density polyethylene construction sourced entirely from sugarcane ethanol is recyclable, reducing the carbon footprint associated with this product type. Design. Because hard hats are intended to protect the wearer's head from impacts, hats are made from durable materials, originally from metal, then fiberglass, and most commonly rigid plastic. Some contemporary cap-style hard hats feature a rolled edge that acts as a rain gutter to channel rainwater to the front, allowing water to drain off the bill, instead of running down the wearer's neck. A cowboy hard hat is a hard hat resembling a wide-brimmed cowboy hat, although some organizations disallow their use. Organizations issuing hard hats often include their names and all logos on the front of each hard hat. Accessories. Hard hats may also be fitted with a visor, as in a welding helmet, or a safety visor. An extra wide brim attachment for additional shade. Ear protectors. Mirrors for increased rear field of view. A small device that is used to mount a headlamp or flashlight to a hard hat. The mounting device frees hands to continue working rather than having to hold a flashlight. A chin strap to keep the helmet from falling off if the wearer leans over. Thick insulating side pads to keep sides of the head warm. Examples are seen in ice road truckers. Colors and identification. Hard hat colors can signify different roles on construction sites. These color designations vary from company to company and worksite to worksite. Government agencies such as the U.S. Navy and DOT have their own hard hat color scheme that may apply to subcontractors. On very large projects involving a number of companies, employees of the same company may wear the same color hat. The most common color scheme is white for managers, engineers, foremen or supervisors. Other hard hat styles may be required for a job. Brown fiberglass hard hats are worn by welders and other workers for high heat applications. Green often signifies a safety inspector, but is also occasionally used for new workers. General laborers and earth-moving operators often wear yellow. Carpenters, technical advisors and temps may wear blue. Orange is sometimes used for road crews, new employees or visitors. Some companies offer loaner hard hats in pink for workers who forget their own hard hat. At one time, blasters traditionally wore red. Stickers. Supervisors often are not familiar with all workers on a construction site. Often, stickers, labels and markers are used to mark hard hats so that important information can be shared. Paint or permanent markers can degrade the plastic in hard hats. Instead, labels or masking tape are often applied to a hard hat with the worker's name written on it. Stickers with company logos are very common. Stickers that indicate a worker's training or qualifications are also very common. Many companies provide ready-made stickers to indicate that a worker has been trained in electrical safety, confined space safety, excavation trench safety, or operation of specialized equipment. Environmental monitors often make stickers to indicate that the worker has been educated on the risk of unexploded ordnance or the archaeological-biological sensitivity of a given area. Stickers may indicate who is authorized to be present on site. Unions may offering free stickers for hard hats and other objects. A hard hat also provides workers with a distinctive profile, readily identifiable even in peripheral vision, for safety around equipment or traffic. Peripheral vision registers shapes but not colors. The obvious shape of a hard hat is therefore easier for machine operators to recognize and avoid. Some companies also require reflective tape to be applied to hard hats to increase visibility of workers at night. Standards. In 1997, the American National Standards Institute revised its Performance Z89.1 standards for hard hats that has been harmonized with CSA Z94.1 standard. Conformity to these standards is not mandatory, but most manufacturers comply. Each hard hat is specified by both type and class. Types: ANSI Type I/CSA Type 1 hard hats meet stringent vertical impact and penetration requirements. ANSI Type 2/CSA Type 2 hard hats meet both vertical and lateral impact and penetration requirements and have a foam inner liner made of expanded polystyrene. Classes: Class E provides dielectric protection up to 20,000 volts. Class G provides dielectric protection up to 2,200 volts. Class C provides no dielectric protection. A hard hat is specified by both type and class. For example, Type I Class G ANSI standards for hard hats set combustibility or flammability criteria. ANSI Z89 standard was significantly revised in 1986, 1997 and 2003. The current American standard for hard hats is ISEA Z89.1-2009, by the International Safety Equipment Association that took over publication of the Z89 standard from ANSI. The ISO standard for industrial protective headgear is ISO 3873, first published in 1977. In the UK, the Personal Protective Equipment Regulations 1992 specifies that hard hats are a component of PPE and, by law, all those working on construction sites or within hazardous environments are required to wear hard hats. In Europe, all hard hats must have a manufacturer-set lifespan. This can be determined from the expiry date or a set period from the manufacture date, which is either stuck to the inside or embossed in the hard hat's material. Examples: see also, goggles, protective clothing, safety engineering, steel toe boots. References